Ladies and gentlemen, this is our seminar number 9. Today we'll continue with probability distributions and we will practice hypergeometric distribution, Poisson distribution, and we will return to binomial probability distribution. So these three important probability distributions, discrete distributions, yes, will be our topic, yes, for today's seminar. And of course, I will show to you the approximation of different distributions. So make ready paper, calculator. Finally, we will use Microsoft Excel, yes, and we can start. We will solve this example. At the police station, it is necessary to change 3 light bulbs in the candle. So 30 bulbs are lying in the warehouse, but 5 of them were damaged during the last police shot exercise. What is the probability that we will select only that light bulbs which were not damaged? So I will use this paper and I will draw here a picture. So this is my warehouse and I know that 30 bulbs are lying in the warehouse, yes. I know that 5 of them were damaged during the last police shot exercise, and I need to select 3 bulbs, yes. So this is my random selection, yes, random selection of 3 bulbs from the warehouse. This is the population, total number of bulbs in the warehouse, and this can be denoted like a special characteristic. Yes, special characteristic. The bulb is damaged. Yes, the bulb will not shine in the candle. So you can see that we have here three important informations, and in our situation, random variable x. Yes, using these 3 important information parameters. Yes, and this variable has hypergeometric distribution with parameters capital N, capital M, and small n. Yes, in our situation, this is hypergeometric distribution with parameters 30, 5, and 3. Yes, and what is our duty? What is the probability that we will select only that light bulbs which were not damaged? We would like to calculate probability that random variable x will be equal to 0. 0 damaged light bulbs in our selection. So I will use your formulas. And I will write here the probability function for the hypergeometric distribution. It's a multiplication and division of 3 combination numbers. Yes, there is capital M above x. Yes, the first combination number times second combination number capital N minus capital M above small n minus x. Yes, and there is division, and the third combination number is in the denominator. There is capital N above small n. So you can see it's just multiplication and division of three combination numbers, nothing more. So I will use this probability function and I will calculate this. So 5 above 0, yes, times. And now 30 minus 5 above 3 minus 0. Yes? Do you know what is x? Do you know what is capital M, capital N, small n? Yes? We have parameters, we know everything, so we will use this. And there is a division, and in denominator we have combination number 30 above 3. Yes, and that's all. Now, you can use the calculator and you can calculate 5C0, yes, times 25C3 divided by 30 combination number C3 and equal sign, yes? So I will use this calculator and I will calculate 5 combination number 0 times 25 combination number 3 divided by 30 combination number 3. Enter. Result is 0.5665. Yes. So this is probability that random variable x will be equal to 0. Yes. Number of damaged light bulbs, yes, in our selection will be equal to 0. With this probability, 56.65%. Yes. So what is the probability that we will select only that light bulbs which were not damaged? 56.65%. How many damaged bulbs can we expect on average between 3 randomly selected bulbs and with what variance? So, in your formulas, yes, you can find formula for the calculation of expected value. Expected value of random variable x in the case of hypergeometric distribution. This is calculated like n times capital M divided by capital N. Yes. So in our situation, 3 times 5 divided by 30. Yes. So this is equal to 15 divided by 30, and this is equal to 0.5 light bulbs. Yes. So this is in bulbs, yes, 1/2 of damaged light bulb is the expected value. How can you imagine this value? I will go to the warehouse, yes, and I will select 3 light bulbs. I will use these light bulbs in the candle and everything will be all right, yes, all of them will be all right, all of them will shine in the candle. I will return these bulbs to the warehouse, yes, and you will go to the warehouse, yes. You will select 3 bulbs, yes, from this box. You will check if the bulbs shining in the candle, and you will see that one bulb, yes, one bulb will be damaged, and in average we have 1/2 of damaged bulbs, yes, in this selection. So this is expected value, 1/2 of damaged bulbs, and variance of this variable x in your formulas you can find n times capital M divided by capital N times 1 minus capital M divided by capital N, yes, and times capital N minus small n divided by capital N minus 1. Yes, so I will use the values which I know, so 3 times 5 divided by 30 times 1 minus 5 divided by 30 times 30 minus 3 divided by 30 minus 1. Yes, so this will be the variance. So I will use the calculator. There I know that I have 15 divided by 30 times 1 minus 5 divided by 30, close the parenthesis, times, and there is a ratio 27 divided by 29. 27 divided by 29. Enter. And the result is 0.388. 0.388. So this is the variance. But you know that this variance, yes, is in squared units, so I am not able to interpret this result because I don't know what is it squared bulb, yes, squared light bulb. So there is written because of difficult interpretation of variance, calculate also the standard deviation. We know that standard deviation of random variable x is calculated like square root from the variance Vx. So in our situation, square root from value 0.388. Yes, I have this value here. Yes, you can see with a lot of decimals. So I will use square root and I will use this result, enter, and the deviation 0.623. 0.623, I will write it here, 0.623 bulbs. Yes, because standard deviation is in basic units, in original values, so in bulbs. Yes. Okay, so we calculated everything. We will solve this example. To the small store will come 30 customers in average during 1 hour. What is the probability that within 4 minutes will come to this store? And there we have A, B, and C. So, what is the most important information here which we have? I will use the paper and I will write here. We have 30 customers. Yes, 30 customers in average during 1 hour. Yes, and the most important information, what is the probability that within 4 minutes I must recalculate this important information from 1 hour to 4 minutes. Yes, I can expect that 0.5 yes, customer will come during 1 minute. Yes, within 1 minute I can expect 1/2 of customer. So 2 customers, yes, can be expected within 4 minutes. Yes. Do you know how I recalculate this information? 30 customers within 1 hour. I know that 1 hour has 60 minutes. Yes. 0.5, 1/2 of customer within 1 minute. Yes. So 2 customers within 4 minutes. So this is the most important information for me. I don't need this information anymore, and I don't need this information anymore. Yes? Okay, so what is the probability that within 4 minutes will come to this store? It's important that 30 customers in average during 1 hour. So 2 customers within 4 minutes, yes, this is my expected value. I can expect, yes, 2 customers within 4 minutes. And if you check your formulas, you can find here that expected value equal to parameter lambda is the case of Poisson distribution. Poisson distribution. In your formulas, you can see that this Poisson distribution has expected value equal to 1 parameter lambda, and variance of this random variable with Poisson distribution has also is also equal to this parameter lambda. Yes, so this Poisson distribution, Poisson using only 1 parameter lambda, and we know this parameter. Yes, so we can solve everything because we would like to calculate the probability that within 4 minutes will come to this store exactly 2 customers. I would like to calculate probability that random variable x will be equal to 2. Yes, I will rewrite the probability function from your formulas. We need Euler constant E powered by minus lambda times. There is lambda powered by x divided by x factorial. Yes. Okay, so this is the probability function, and I will calculate probability that random variable x will be equal to 2. So Euler constant powered by minus lambda. Lambda is equal to 2, so powered by minus 2 times lambda 2 powered by x. X in our situation is also 2, yes? So powered by 2 divided by x factorial 2 factorial, yes? Okay, so we can use calculator and we can try to calculate Euler powered by minus 2 times 2 powered by 2 divided by 2, and I must find a factorial function. Enter. 0.2707. Okay, so we can interpret this in percent like 27.07%. Yes, so this is the probability. Yes, this is the probability that within 4 minutes will come to this store exactly 2 customers. Okay, we will continue. At least 3 customers. At least 3 customers. What is it? Probability that random variable x will be higher or equal, at least 3, yes? Higher or equal to 3. So what it means? Probability that random variable x will be equal to 3. Or probability that random variable x will be equal to 4 customers, yes? Or 5 customers, or 6 customers, yes? And you can continue, and we don't know where is the end. So it will be better for us to calculate probability that random variable, or 1 minus, yes, probability that random variable x will be smaller than 3. Yes, this will be much more easy. 1 minus, and there will be what? Probability that nobody come to this store, or probability that one customer will come to your store, or probability that 2 customers will come to your store. Yes, 1 minus this summation. Yes, so we need to calculate the summation of 3 probability functions. Yes, we know probability function for a Poisson distribution. Yes, so I will use this here. Euler constant powered by minus lambda. Yes, times lambda powered by x, yes, divided by x factorial. So this is the first probability function, yes, plus probability that random variable x will be equal to 1. Euler constant powered by minus lambda, yes, times lambda powered by x divided by x factorial, yes, and last probability function Euler powered by minus lambda times lambda powered by x divided by x factorial. Yes, okay, so I will solve these 3 probability functions. Yes, so the first one, Euler powered by minus 2 times 2 powered by 0 divided by 0 factorial. Enter. So the first value, yes, I will write the first value. Probability 0, yes, is equal to 0.1353. 1353. Yes, first important result. Okay, I will continue. Yes, this one. So, Euler powered by minus 2 times 2 powered by 1 divided by 1 factorial. Enter. 0.2707. So probability that variable x will be equal to 1 is 0.2707, and we already calculated probability that random variable x will be equal to 2. It's the same value, 0.2707. Yes, so you have here 3 partial results. So we can calculate 1 minus summation of these 3 values. Yes, summation of these 3 values. Okay, so 0.1353 plus 0.2707 plus 0.2707. Enter. 1 minus 0.6767. Yes, and this is equal to 1 minus this value 0.3233. 0.3233. So you can interpret this value in percent like 32.33%. Yes, so this 1 minus probability that random variable x will be smaller than 3 is equal to 32.33%. yes? So this is response B. This is response B, yes? Okay, so we calculated A, yes? A 27.07%, B 32.33%, and C at least 3 and at most 5. Probability that random variable X will be higher or equal to 3, smaller or equal to 5, yes? So this can be calculated like probability that random variable X will be equal to 3, or probability that random variable X will be equal to 4, or probability that random variable X will be equal to 5, yes? So again, it's a summation. It's a summation of 3 probability functions, yes? So I will use a paper and I will calculate probability that variable X will be equal to 3, probability that variable X will be equal to 4, and probability that random variable X will be equal to 5. So Euler constant powered by minus lambda times lambda powered by X divided by X factorial, yes? Okay, you can continue. Euler powered by minus lambda times lambda powered by X divided by X factorial. Euler powered by minus lambda times lambda powered by X divided by X factorial, yes? So you can solve these 3 probability functions. So I will use the calculator. Again, Euler powered by minus lambda times 2 powered by 3 divided by 3 factorial. Enter 0.1804. 1804. This value. Euler powered by minus lambda times 2 powered by 4 divided by 4 factorial. 0.0902. And this value, Euler constant powered by minus lambda times 2 powered by 5 divided by 5 factorial. 0.0361. Okay. So summation, the sum of these 3 values, 0.1804 plus 0.0902 plus 0.0361. Enter 0.3067. So this is probability that random variable X will be higher or equal to 3 and smaller or equal to 5, yes? It can be interpreted in percent like 30.67%, yes? 30.67% is the probability that within 4 minutes will come to this store at least 3 and at most 5 customers. So I will write here 30.67% is response C. We know that expected value is equal to lambda to customers. Variance is equal to 2, but this is in squared units, yes? I am not able to interpret this value, so it's possible to calculate standard deviation of this random variable x, square root from 2, square root from the variance, yes? Square root from the variance, so standard deviation, square root from 2, enter 1.42 customer, yes? 1.42 customers. Proofreading of 500 pages of book revealed that it contained 500 misprints. So you wrote a book, yes, with 500 pages, and the technical editor, yes, found 500 misprints. So we would like to find a probability that on one page are at most 5 misprints. What we know, on 500 pages, you can expect 500 misprints, yes? There is written, find a probability that on one page, so it's necessary to recalculate this information on one page, yes? It's very easy in this situation. On one page, yes, you can expect one misprint in average, yes? One misprint in average you can expect on one page. This is very important information. I can expect, yes, I can expect on average one misprint on one page. This is only one information which I have. So this one is my lambda of the Poisson distribution, where lambda is equal to 1. Yes? So I will calculate probability that on one page are at most 3 misprints. What is it? At most. Probability that random variable x will be smaller or equal to 3, because this is discrete distribution. I can solve this like probability that there will be no misprint, or 1 misprint, or 2 misprints, or 3 misprints, because there is equal sign, yes? So either 0 or 1 or 2 or 3, because I explored that this is again Poisson distribution with this parameter, yes, lambda equal to 1. So I can use this probability function, Euler powered by minus lambda times lambda powered by x divided by x factorial. In our situation, Euler powered by minus 1 times 1 powered by 0 divided by 0 factorial plus Euler constant powered by minus lambda times lambda powered by 1 divided by 1 factorial. And we can continue, plus Euler powered by minus lambda times lambda powered by 2 divided by 2 factorial. And finally, Euler powered by minus lambda times lambda powered by 3 divided by 3 factorial. Okay, I will use the calculator and I will solve this. So that is Euler powered by minus 1 times 1 powered by 0 divided by 0 factorial. 0.3679 plus, and we can continue. Euler powered by minus 1 times 1 powered by 1 divided by 1 factorial. 0.3679, yes? It's okay, yes? It's true that this value and this value is the same, yes? Plus Euler powered by minus 1 times 1 powered by 2 divided by 2 factorial. 0.1839 plus, and finally Euler constant powered by minus 1 times 1 powered by 3 divided by 3 factorial. 0.0613. Okay, I will calculate the summation. Yes, summation of these four values: 0.3679 plus 0.3679 plus 0.1839 plus 0.0613. Enter. 0.981. So this is the result which can be interpreted in percent like 98.1%. So this is the probability that on one page, yes, are at most 3 misprints. So either 0 or 1 or 2 or 3. We will solve this example in a big population of 10,000 people. There are 100 people left-handed. If we randomly select 50 persons without returning, what is the probability that there are among them? And we have here 3 questions, yes? Nobody left-handed, exactly 3 left-handed, and at least 3 left-handed. What is important here? The population, yes, of the people can be denoted like capital N. Yes, capital N is equal to 10,000 persons, 10,000 people, yes? And we know that there is one special characteristic that a person is left-handed. Special characteristic can be denoted like capital M. So this is equal to 100, yes? And our random selection without returning small n is equal to 50. You can already expect, yes, that this will be hypergeometric distribution with parameters 10,000, 100, and 50, yes? So we already had this example before, so we are able to try calculate this, yes? So what is A, nobody left-handed? We would like to calculate probability that random variable x, number of left-handed persons in our selection, will be equal to 0, yes? Nobody left-handed. We know that probability function of the hypergeometric distribution is equal to, there is combination number, capital M, above x times capital N minus capital M above small n minus x, yes? And this is divided by this combination number, capital N above small n. Okay, so we will calculate this probability, yes? Probability of 0. Probability of 0 is equal to, so, capital M, 100 above 0 times 10,000 persons minus 100, above 50 minus 0 divided by, and there I have 10,000 above small n, 50. Okay, so this is combination number 100 C0 times there is 9,900 C50 divided by 10,000 C50. Yes, so I can try to write it to this calculator. 100 combination number 0 times 9900 combination number 50 divided by 10,000 combination number 50, enter. You can see that this calculator has not enough memory for the calculation of such large example, yes, because there is a lot of combinations, and this calculator has not enough power for the calculation of this. So we will solve this in Excel. Yes, I will show to you how to solve this in Excel, but I will prepare for you also the last two things. Exactly 3 left-handed persons, yes? So what is it exactly? 3 probability that random variable x will be equal to 3, yes? So I will use this probability function, and there will be 100 above 3, yes, times 10,000 minus 100 above 50 minus 3, yes, divided by 10,000 above 50. Yes, so I will rewrite this like 100 combination number 3 times 9,900 combination 47, yes, divided by 10,000 combination 50. Yes, I will not try to solve this because this calculator has not enough memory for the calculation of these combination numbers. Yes, so we'll solve this in Excel. And finally, I will prepare for you at least 3 left-handed. Yes, so what is it? At least 3. Probability that random variable x will be higher or equal to 3. Yes, so what is it? Probability that we will select 3 left-handed persons, 4 left-handed persons, yes, 5 left-handed persons, etc. So it will be better for us to solve this like 1 minus probability that random variable x will be smaller than 3. So what is it? 1 minus, and here I will calculate a summation. Probability that I will select nobody left-handed, or 1 left-handed, or 2 left-handed. Yes, probability that x will be smaller than 3. Yes, 1 minus probability that x will be smaller, not equal, yes, smaller. So either 0 or 1 or 2. Okay, so we need to calculate probability. I will select 0 left-handed persons, 1, 2, and 3. Yes, so I am missing for this calculation probability that I will select 1 left-handed person. So according to this probability function, there will be 100 above 1, yes, 100 above 1 times 10,000 minus 100 above 50 minus 1, yes, and this will be divided by, and there is 10,000 above 50. Yes, so this will be probability that I will find one left-handed person. I will rewrite this like combination number 100C1 times 9,900 C49 divided by 10,000 C50. Okay, and finally, probability that we will select two left-handed persons, yes, equal to 100 above 2 times 10,000 minus 100 above 50 minus 2. Yes, this is divided by, and there we have 10,000 above 50. So this can be rewritten like 100 C2 times 9,900 C48 divided by 10,000 C50. Okay, so everything will be solved in Microsoft Excel. Because of lack of memory in our calculators, I will solve the values of probability in Microsoft Excel. So I will set here the parameters which I have capital N, capital M, and small n. Yeah? So I will prepare here these parameters. We have a population of 10,000 people, yes, 100 left-handed persons, and 50 persons is our selection, yes. I will write here hypergeometric distribution HY, yes, and there will be random variable x. Yes, random variable x will be here, and we need to calculate value for 0, 1, 2, and 3. Yes, so there will be random variable x, and here below hypergeometric distribution, I will calculate probability. Yes, I will calculate here probability that random variable x, yes, will be equal to these values. And according to probability function which you have written in your formulas, yes, I will start with writing. Formula. Okay, I hope that it's visible. So there will be equal sign. Combine, yes, returns the number of combinations for a given number of items. So combine, and first combination number is capital M above x. Capital M is here. I will use function 4 button on the keyboard, yes. So because this is a parameter, so there is capital M above x. X is variable, so don't use function 4 here. So this is the first combination number. Now times another combination number. Combine returns the number of combinations for a given number of items. Open the parenthesis and open the parenthesis one more time because there is a difference. Capital N minus capital M. Yes, capital N function 4 because this is a parameter minus capital M, this again function 4 because this is a parameter. Yes, close first parenthesis and this is above, so open the parenthesis. This is above small n minus small x, so 50, use function 4 because this is a parameter, minus small x, x is variable, yes, close parenthesis and close parenthesis one more time, yes, okay, so first combination number, yes, times second combination number divided by third combination number, yes, so right here division and again combine, open the parenthesis and in denominator we have capital N, 10,000, use function 4 because this is a parameter, above small n, 50, again use function 4 because this is a parameter, close the parenthesis. Okay, and that's all. Please press enter, yes, and use 4 decimal places, yes. One more time, I will show for you this function. Yes, you can, for example, use print screen and try to calculate this at home because you can see it's not difficult. Yes, everything what is the variable is not fixed, and everything what is the parameter is fixed with dollars. Yes. Okay, so this is probability that random variable x will be equal to 0. This is probability that random variable x will be equal to 3. So this is our response. This is our response A. Yes, probability that nobody left-handed person, yes, will be in our selection. This is probability of B. Probability that we will have exactly 3 left-handed persons in our selection. Yes, you can see 1.20%. Yes, and C probability that we will have at least 3 or 4 or 5. Yes, etc. And we calculate this. Like 1 minus, I will write it here, 1 minus probability, as the random variable x will be smaller than 3. Yes, so this is our C. Yes, and we can solve this like 1 minus 0. Yes. Minus 1 minus 2. Yes. Okay, so 1.35%. So this is our response C. Yes. A, B, and C. We solved this in Microsoft Excel because our calculator was not able to solve this because of extreme large number of combinations. We will try approximation of one distribution by another distribution. Yes, can you see we have here 100 left-handed persons in population of 10,000 persons. Can you calculate the ratio m divided by n. In our situation, 100 persons, left-handed persons, divided by population 10,000. The result, 100 divided by 10,000 is equal to 0.01. What is it, this value? This is the probability. This is the probability that I will select left-handed person from the population, yes? And our sample, yes, is 50 persons, yes? So I have a selection, random selection, 50 persons, and this is the probability that I will select left-handed person from the selection. So now I reduced 3 parameters to 2 parameters only. I have here n and p 0.01, and this will not be hypergeometric distribution anymore. But I will try to solve this example by binomial probabilistic distribution with parameters n and p. Yes, binomial distribution with parameters 50 and 0.01. Can you find probability function in your formulas? Probability that random variable x will be equal to x can be calculated like n above x, yes, times p powered by x times 1 minus p powered by n minus x, yes. And here you can see that we try to calculate probability that I will find nobody left-handed, yes. I need to calculate probability that I will find 1 left-handed person, 2 left-handed persons, yes, and 3 left-handed persons. So, according to this probability function, yes, I will use these 2 parameters, and I will calculate probability that I will find nobody left-handed in my selection. So 50 above 0 times p 0.01 powered by 0 times 1 minus p, 1 minus 0.01 is 0.99, yes, powered by 50 minus 0, yes, so we will calculate this. And we can continue. Probability that I will find 1 left-handed person, yes, 50 above 1 times 0.01 powered by 1 times 0.99 powered by 50 minus 1, 49, yes? So there will be another result. And here, probability that I will find 2 left-handed persons, 50 above 2 times 0.01 powered by 2 times 0.99 powered by 50 minus 2. 48, yes, will be here. Okay, and finally, probability that I will find 3 left-handed persons, yes? So, 50 above 3 times 0.01 powered by 3 times 0.99 powered by 50 minus 3, 47, yes? Okay, so you can use calculator and you will see that you are able, on your calculator you are able to calculate these results, yes? Okay, 50 combination number 0 times 0.01 powered by 0 times 0.99 powered by 50. Enter. 0.6050. So this is probability that you will find nobody, no left-handed person in this selection. Yes? We can continue. 50 combination number 1 times 0.01 powered by 1 times 0.99 powered by 49. Enter. 0.3056. So this is probability that you will find one left-handed person in this selection. Yes? And we can continue. 50 combination number 2 times 0.01 powered by 2 times 0.99 powered by 48. 0.0756. Yeah, so this is probability you will find two left-handed persons and 3. 50 combination number 3 times 0.01 powered by 3 times 0.99 powered by 47. 0.0122. Okay, so the response, yes, the response on these questions, yes, according to binomial distribution, nobody, yes. So this is A. According to binomial distribution, exactly 3, so this is B, yes. 1.22%, 1.22%, this is B, and at least 3 will be calculated like 1 minus probability 0, 1, and 2. Yes, so the C will be calculated like 1 minus 0, 1, 2. So 0.6050 minus 0.3056, 0.3056 minus 0.0756, 0.0756. Okay, equals sign. I will solve this. 1 minus 0.6050 minus 0.3056 minus 0.0756. So result 0.0138. So this is response C. Yes, according to binomial distribution. Yes, so there is A, there is B, binomial distribution, and there is C, binomial distribution. We can continue. Do you know how can you calculate expected value? Expected value in the case of binomial distribution. In the case of binomial distribution, you can calculate this expected value like multiplication n times p. In our situation, 50 times 0.01. Yes. Okay, so I will solve this. 50 times 0.01. This is equal to 0.5. Yes. So binomial distribution has expected value equal to 0.5. Yes. And Poisson distribution using expected value equal to lambda. So I will reduce these two parameters to one parameter lambda equal to 0.5, and I will try to recalculate everything one more time with this one parameter lambda. Yes? So do you remember probability function of Poisson distribution, Euler powered by minus lambda, yes, times lambda powered by x divided by x factorial, yes. So now I will try to calculate everything one more time. Probability 0, probability of 3, and probability that random variable x will be higher or equal to 3. Yes? Okay, so I will write it here. Probability 0, probability 1, yes, probability 2, and probability of 3. Okay, so according to this probability function, which is written here, yes, so Euler constant powered by minus lambda, powered by minus 0.5 times lambda 0.5 powered by 0 divided by 0 factorial. And you can continue, yes? Euler powered by minus lambda 0.5 multiplication times 0.5 powered by 1 divided by 1 factorial, yes? And here there will be equal sign Euler powered by minus lambda 0.5 times 0.5 powered by 2 divided by 2 factorial, yes? And here there will be equal sign Euler powered by minus 0.5 times 0.5 powered by 3 divided by 3 factorial, yes? And now you can try to solve this, yes, on your calculator. So I will use this calculator, and there is Euler powered by minus 0.5 times 0.5 powered by 0 divided by 0 factorial. Enter. 0.6065. 6065. Yes. So this is response A. Yes. According to Poisson probability distribution. And we can continue. Yes. Here Euler constant powered by minus 0.5 times 0.5 powered by 1 divided by 1 factorial 0.3033. Yes, so this is probability that we will find one left-handed person in our selection. And we will continue here. Euler constant powered by minus 0.5 times 0.5 powered by 2 divided by 2 factorial 0.758. Yes, this is the probability that we will find two left-handed persons in our selection. Yes, and this probability that random variable x will be equal to 3. So Euler powered by minus 0.5 times 0.5 powered by 3 divided by 3 factorial 0.0126. This is response B, yes, according to Poisson distribution. Yes, this is the probability. This is the probability that we will find exactly three left-handed persons. Yes, and finally, response C, according to Poisson distribution, at least 3 left-handed. Yes, this will be calculated like probability. The random variable x will be higher or equal to 3. I will solve this like 1 minus probability that x will be smaller than 3. So I will solve this like 1 minus probability that random variable x will be equal to 0 minus probability that random variable x will be equal to 1 and minus probability that random variable x will be equal to 2. Yes, Poisson distribution and results I have here. Yes, so 1 minus 0.6065 minus 0.3033 minus 0.0758. Yes. Okay, so I will use the calculator. 1 minus 0.6065 minus 0.3033 minus 0.0758, enter 0.0144. So this is response C according to Poisson probability distribution. I will try the approximation here in Microsoft Excel. Yes, we approximate by binomial probability distribution. Yes, binomial distribution. So I will try to calculate these probability functions of binomial distribution here. Yes, what we need for the binomial distribution parameter P. Yes, small Greek letter P, and this P will be calculated like ratio. Yes, capital M divided by capital N. Yes. And this parameter is equal to 0.01. This is the probability. This is the probability that selected person, yes, from our selection will be left-handed. Yes. So I will use only these two parameters here in this column. Yes, only these two parameters. according to probability function of binomial distribution. Do you remember probability function for binomial distribution? Equal sign, yes? Again, there is a combination number, so I will use function combin, yes? Combin, and there is n above x, so small n, please use function for above x, yes? X is variable, so it's not fixed. Close the parenthesis, yes? Times P, probability that selected person will be left-handed, yes? This is parameter, so you must use function for, and power function, this is powered by x. X is variable, yes? Times, and there in parentheses we have 1 minus p, yes? So the result is 0.99. 1 minus probability p, use function for because this is a parameter and this is powered by, so we use this hat power function, this is powered by small n minus x, yes? This value 50, use function for because this is a parameter, minus x, x is variable, yes? Close the parenthesis. And I hope that everything is alright, yes? So please try this also at home in your Microsoft Excel. Press enter and use only 4 decimal places, yes? 4 decimal places. You can see that this is your response A. This is your response B, and this is your response C. As you can see, I will show to you this function one more time. As you can see that we used only these two parameters, n and p, as for the binomial distribution. And this is variable. Everything what is variable don't have dollars, yes? Everything what is a parameter must have dollars, must be fixed, yes? The cell must be locked. Okay, so you can compare the results, yes? We use one distribution and different distribution, yes? And we have very small differences, only small differences between hypergeometric and binomial distribution. There is 1.35%, there is 1.38%, very, very small difference, yes? The results are all similar. We can continue with Poisson distribution, yes? Poisson distribution, and we can calculate probabilities, yes? Probabilities. Do you remember the probability function for Poisson distribution? Exponent, Euler constant, yes? Do you know the value of Euler constant? Euler constant, exponent returns e, rise to the power of a given number, yes? Euler constant is 2.718, etc. This is the base of nature logarithm, yes? The base of nature logarithm, yes? Exponent Euler constant. So this Euler constant, yes, this exponent, this e, yes, is powered by minus lambda. But I don't have lambda calculated here. I must calculate lambda here, yes? Lambda, okay, yes, lambda. And lambda is calculated like n times p, yes? N times p, so this is lambda. And this lambda will be used here, yes? no other parameters will be used. Yes? So we know that we must start with e, exponent, yes? Exponent powered by minus lambda. I will use only this one parameter. This is parameter, so you must use function 4. Yes? So this is exponent powered by minus lambda times lambda powered by x. Yes, where is the lambda? Here is lambda, function 4, powered. So find this hat, power function, powered by x. X is variable, so don't use dollars here, yes? Divided by, and there is in denominator x factorial. Factorial has function fact. FACT returns the factorial of a number. FACT, yes? FACT is factorial of x. X is variable, so don't use dollars. And close the parentheses. And that's all. This simple function is probability function of Poisson distribution, so you can copy the formulas. This is our response A, this is our response B, and this is our response C. So we solved this example. According to 3 different probability distribution: hypergeometric, binomial, and Poisson. And you can see that there is 60 point something percent. Yes, there is 1.2, and something small, yes? So very small differences, 1.75, 1.78, 1.44%, again small differences, yes? If these values, the population and the sample size, yes, if these values are higher, bigger, yes, these values, these results are more and more similar, yes? If you have the city with 1 million inhabitants, yes, and if your selection will be, for example, 1,000 of persons, yes, these results will be probably identical, yes, almost the same. So this is approximation of probability distributions. Ladies and gentlemen, this is the end of our 9th seminar. Next week we will continue with continuous probability distribution. Yes, we will start with one of the most important probability distribution, the normal distribution. Yes. And other important topics which are connected with normal distribution. So that's all for today. Have a nice day. I hope that I will see you next week, and bye bye.